Introduction to Aerodynamic Objects Tutorial 3, my first wing. And in this you're going to make a wing-like object that generates lift and understand the important concept of angle of attack. We're going to make a flat wing-like object that can generate lift, and then we're going to vary the angle of this object relative to the wind and see how this varies lift. Then we're going to keep the wing fixed and vary the wind and then see how that changes lift, and then finally bring it all together to understand how that lift force depends on angle of attack. So this is our scene diagram for the tutorial. The important bit here is the diagram of what we're modelling, and we've got a wing here, so I've drawn a grey aerofoil shape here. We're actually modelling this as a flat plate, the thing in the middle, and the important thing here now is that this plate is at an angle to the wind, so this is the angle of attack, and as before, drag is the force parallel with the wind, but lift is the force perpendicular to the wind. And we're modelling this same as before. We've got a fluid zone which we're setting up wind, where we can vary speed and direction, and then our aerodynamic object is made up of our three objects of a rigid body, a geometry body, and then a body that contains the aerodynamic components. So here we are in Unity. I've created a new scene, called it Tutorial 3, Work in Progress. So we're going to do the usual scene setup we've done before. First thing we're going to do is add a flow field. So right click, create empty, call it flow field, and we're going to add our fluid zone to this. So aerodynamic objects, fluid zone. Check it's all in the right place, default values, that's good, and we're also going to add some flow field arrows, and we have to subscribe to the fluid zone, so drag that across there, leave all those at the default values, and we need to add in some cameras so we can see what's going along, so just drag in the AO cameras. Okay, give that a quick play to make sure that's all working. Okay, we've got our wind as usual and set up in a box 10 by 10. Okay, that's great. Let's get on and make our wing. So right click, create empty, call that wing. Top level hierarchy, we're going to add in a rigid body, and we can leave all those settings the same, apart from we're going to fix it in space, so I'm going to click that as kinematic. Next level down we need some geometry, so I'm going to do 3D object cube, and then I'm going to rescale it to be wing shaped. And remember, the coordinate system we're always using, Z is always forward, X is to the right, Y is up, so we're going to make the wing stretched in the X direction. So let's make it 8 meters long, and let's make it nice and thin in that direction, so 0.05, and let's leave that at 1. So we've got ourselves a reasonably shaped wing there, with that pointing forwards in our world. Okay, that's the geometry, so let's just call it that. And now we have to add the aerodynamic part to it, so once again we're going to create an empty, and we're going to call that aero object. So we are going to add an aero object script component to that. So had drag before, but this time we've also got lift. We need to connect it up with the rigid body, so it knows what it's doing. And if we put gizmos on here, we can see this squashed blue ellipsoid shape. That's the shape that the aerodynamics is using to approximate this wing. And you can see, so it's reasonably thin, and it will generate some lift. Okay, we need to add our sphere collider onto this, so it detects the wing zone, and it's a trigger. And let's just make this small so it doesn't get in the way, and add some visualization components. So we're going to add a wind arrow. We can leave those as defaults, and we're going to add a drag arrow. Again, we can just leave those as they are, and a new, for this time, a lift arrow. Okay, that's all set up. Let's give it a play and see what happens. Okay, we left our turbulence on, so the thing's wobbling all over the place, but it's definitely doing something. I'm going to go to my fluid zone here, and I'm going to uncheck turbulence, and I'm going to lock that so that it stays in the same place. Okay, so now we've just got some steady wind, and it's kind of helpful to do this in the scene view so that you can see where you are in terms of the axes. So Z is forward in our world. We've got the wind coming straight at the wing. It's actually not doing very much because there's no angle of attack. So it does produce drag, but actually not very much because it's facing directly into the wind. Turn that back to 1. And what I'm going to do now is, to make the wing generate lift, we need it at an angle to the wind. So I'm actually just going to vary the, if I go to the top level of this object here, and I vary the X component of the Euler angles, I can twist the wing up. And as I lift the wing up like that, you can see that now the flow is coming from sort of kind of underneath the wing, and we're generating a lift force. So I can carry on increasing the angle there. Lift goes up, then it drops down, so the wing's actually stalled. Lift is going down, drag is going up, and then once you get to an angle of attack of 90 degrees like that, the wing is just producing drag and no lift. And in fact we can carry on all the way around, so now actually the wing is working upside down, so it's lifting downwards. So if that was on a racing car, that's what you'd want. You want it pushing the car on the ground, and then we're back to where we started from there. So wheel it all the way back, and there we go. Okay, so that's how we generate lift on a wing. We put it at an angle to the flow, and we generate our lift force. And if you notice here, the lift is much bigger than the drag, and that's the job that a wing does. The idea, it's a shape that generates lots of lift and not so much drag, and that's good for making an aircraft or anything else you want to do with wings. Great, so that's varying the angle, but in fact in this world we can vary the angle of the wind as well. So what I'm going to do is set this back to 0, but this time I'm going to change the wind direction. So if I move the wind coming from underneath, so the wing is coming from underneath, we can see now that we're generating lift. You go all the way, so now the wind is coming directly underneath, so that's just drag like we've seen before, and I can go all the way around if I want to. So now this is the wing flying backwards essentially, but it's generating lift. So what we're seeing here is it's not the angle of the wing relative to the ground, it's the angle of the wing relative to the wind that determines the aerodynamic forces. And the other interesting thing we need to look at here is what happens as you vary the azimuth angle. So when your body is not symmetric, your wing still needs to be able to work. And one of the things coded into the aero model here is that your wing will work whatever the side slip or azimuth angle you're at. So as we come around now, the wind is coming from the side. Effectively what the aerodynamics is seeing is just a very, very narrow wing, and from aerodynamic theory that doesn't produce very much lift, but it produces quite a lot of drag. And you can see here we've got a little bit of lift on our wing, but it's mainly drag, and we can carry on round. So now the wind is coming from the back, so our kind of plane is flying backwards, but it's still generating some lift. And then the same, I can go all the way back again, and our wing there is generating lift. And same as upside down. So one of the key features of aerodynamic objects is that whilst there are more accurate ways of simulating a wing aerodynamics, this method is robust, and if you build a wing, whichever way the wind comes at it, it will give you a sensible answer on how that wing would behave in real life. Okay, to summarize then, how do wings work? In a simplistic way, the main thing we have to remember with a wing, it's the angle of the wing relative to the wind that generates the lift. So this angle here is the angle of attack. As before, the drag is always in line with the wind, so it always slows the wing down. The lift is in the perpendicular direction. You may have noticed I've drawn this diagram rotated round from when you first saw it at the beginning, and that's really to emphasize the point that it's not the angle of the wind relative to the horizontal, it's the angle of the wind relative to the orientation of the wing that makes the difference. So this is the angle of attack, and this is the really important thing that determines how your wing behaves, whether it's the wing on a car or a wind turbine or an aircraft. Okay, so that finishes tutorial 3. In the next tutorial, tutorial 4, we'll start building a weather vane, and what we're going to do there is use this wing as the vertical stabilizer on the back of the weather vane, and we're going to understand how the behavior of the wing affects the dynamics of the weather vane, so we can make the weather vane point into the wind whichever way the wind is coming from.